Welcome to the next video in which I am solving previous year KTU problem. So this is a very recent question paper problem. This was from the year 2020 December. It is asked for 8 marks. This is from MOS, which is S3 Civil. And this particular problem is from Module 5, and in Module 5 from column. Okay. There are two formulas in Module 5 column portion that you have to remember. If you remember those two problems, this can be solved very fast. So the problem is a 2 meter long column has a circular cross section of 5 centimeter diameter. Okay, so it's a circular column. One of the end of the column is fixed in direction and position, and other end is free. Taking factor of safety 3, calculate the safe load using Rankines formula, taking yield stress as 560 and Rankines constant as 1 in 1600. Also by Euler's formula with E equal to 1.2 into 10 raised to 5. So this is direct formula question. You just have to apply two formulas. Okay. So first we will draw the column with boundary condition. So here we have a column which is fixed in direction and position, other side is free. So one end is fixed, other end is free. So this is fixed, other is free. The length of the column is given as 2 meters or 2000 mm. Okay, so the moment you get a column length and boundary condition, you have to calculate the effective length. Effective length is nothing but, for cantilever, it is nothing but 2 times capital L. So this is a cantilever column. So that means 2 into 2000. So this is nothing but 4000 mm. So this is the length of the effective length of the column that you have to consider. Now, for other values that is given is sigma is given. Sigma compressive strength of the material is given as 560 MPa. Rankines constant A, or sometimes it is known as alpha, is 1 upon 1600. Then what is given? Factor of safety is 3. E value is given as 1.2 into 10 to the power 5. Okay, and this is a circular column. The diameter of the circular column is given as 5 centimeter or 50 millimeters. Okay, so everything is done. Now we just have to apply formula. Rankines formula we will apply first. Rankines formula. Using Rankines formula, the axial load capacity of column is given by sigma c into area of column divided by 1 plus Rankines constant into effective length upon k to the power square. Okay, now what is k? K is the least radius of gyration. K is the least radius of gyration. Okay, now how do you find k square? So we have to find I equal to a k square. K equal to under root I by a. So in this sigma c is given, a can be calculated, a is given, L is calculated here, k we have to calculate. Now what is the I and a you have to calculate. So first I will calculate I of the section. I is 5 by 64 to the power into d to the power 4. So that is nothing but pi upon 64 into d square. Okay, so this I will calculate. You can also avoid calculating this. So I'll show you how to do that. This you can do. Okay, what we'll do just calculate this. So let's take the calculator out. Okay, so it is nothing but 5 by 64 times the value of d is, I should have written the value of d here, I'm sorry. The value of d is 50 to the power 4. Okay, so it is 50 to the power 4. So this comes out to be, I'm sorry, so this is 306796. 306796. 306796 mm to the power 4. Area is 5 by 4 into d square. So this is pi by 4 into 50 square. So this is, you can calculate pi by 4 into 50 square. So this is nothing but 1963.5 equal to 1963.5 mm square. Okay, so now we can calculate k. K equal to under root I by a. So I is what? 30,306,796 divided by 1963.5. So what is the value of this? Let's just calculate that. We'll quickly calculate this. It is nothing but under root of 30,676,796 divided by 1963.5. So this comes out to be 12.5 mm. Okay, so this is nothing but 12.5 mm. 12.5 mm. Okay, so another way of finding this is, so this direct formula some people remember, you don't have to remember that. So I by a, what is I by a? I by a is, so this is another way of finding k. I by a is nothing but, so pi by 64 into d to the power 4. So 1 by a is 4 upon pi into d square. Okay, so this gives, we can cancel this pi, we can cancel this 4 and 16, so then d square, and here we have d square. This comes to be d square upon 16. So k will be, what will be the value of k? K is nothing but under root I by a, which is nothing but under root of d square by 16 equal to d by 4. So in our case, d is 50, 50 by 4 equal to 12.5. Okay, this is another way of finding. Both are same. You don't have to find both. Either you can use this method. There is a lot of common terms, so you can cancel a lot of common terms and find. So this method is slightly faster because you don't have to find I, you want to find a and all those things. Okay. Now anyway, either way you find k. That's a point. Now we just substitute the values. So P equal to, what is the value of sigma c? Sigma c is given as 560. Now area, since we have calculated, it is we can use here 1963.5 divided by 1 plus 1 upon 1600 times LE by k. What is LE? LE is 4000. 4000 by k is 12.5 square. Now you have to calculate this. So this, you have to be very, very careful when you calculate this. So this is 560 times 1963.5 divided by 1 plus 1 upon 1600 times 4000 upon 12.5 square. Okay, so this gives me the answer as 16916. So 16916 Newton. So remember, the value will be Newton, 16916 Newton, or we can say 16.9 kilonewton. So this is the axial load from Rankines formula. Now you have to find the safe load using factor of safety. So safe load is equal to P upon factor of safety. So 16.9 divided by, what is the factor of safety? It is 3. It is 3. Okay, so this gives me 16.3. So this is divided by 1000 to make a kilonewton, divided by 3, give me 5.6, 5.63 kilonewton. 5.63 kilonewton. Okay, so this is the what we get from Rankines formula. Now you have to find the Euler's formula. So I will do it here. Euler's formula, I will take the Euler's formula. So let's say, so the axial load capacity from Euler's formula is given by buckling load. It is given by pi square E I upon L E square. Okay, so either we can do this, or we can also write pi square E into I is nothing but AK square upon LE square. So this is nothing but pi square E into A times LE by K whole square. So this is nothing but pi square into what is E, 1.2 into 10 to the power 5 into what is area, 1963.5 divided by what is LE by K. LE is nothing but 4000, effective length, K is 12.5 square. So what is the value that we are getting? We will just calculate this again and we will finish our answer. So this is pi square times 1.2 times 10 to the power 5 times 1963.5 divided by 4000 upon 12.5 square. Okay. So this gives me 22709.7. So 22710. 22710 Newton or 22.7 kilonewton. So safe load equal to P upon factor of safety is nothing but 22.7 divided by 3. So 7 point something. Okay. So this 22.7 divided by 3 will give me 7.56. 7.56 kilometer. So this is the answer. Two answers we have found. One is for Rankines formula, one is as per Euler's formula. So this is for 8 marks. It's pretty simple and straightforward. Some calculations are involved, but I hope you understood how to solve this kind of problems. So thank you. We will solve another problem in the next video.